As we work through section 6.3 day 2, you may end up noticing for the first time that you feel a little bit more comfortable with the identities, specifically the proving that's in section 6.3 and the simplifying that's in section 6.1. They're very, very similar where you're using identities to try to manipulate the equations to show that both sides are equal, but the techniques are the same. And when we go through this, we will see a lot of those things come true, and also a lot of your instincts will also come true. Now, for today, both the PDF notes and also your assignment, what it is it's off of the sheets that, again, many of you don't have. But luckily, in the PDF notes, the very first line is the question, and then the work after is how we are going to get to it. So on the sheets, these are actually the numbers that are corresponding with the questions. So don't worry, it's not out of order for your notes. It would, again, just be looking at the pages. So the very first question says, prove this identity. So prove that this equation is true, that the left side is technically equal to the right side. Here is, again, just a recap. When we are doing this, what we have to make sure we do is keep things separate. Don't ever work across the equal sign. Don't try dividing this sign over. Just leave the right side, leave the left side, and you can work on both sides or you can just work on one side. On the last day, we saw a little bit of both. Today, mostly I'll work on just one side. Now, here is what we're going to do. And you can be already trying to get ahead of me in your instincts. If I just looked at this and I said, do something to myself, well, the only thing I can think of is the good old distributive property, where you are multiplying the first term in. And what we would be left with is sine x times cosecant x minus sine x squared. Okay, and so again, let's not forget what we're doing. We're trying to figure out, we're trying to prove that this side is equal to this side, and it always works. It's never a trick question where, it's like, gotcha, kidding, it doesn't actually work. So here's our step that is not in the PDF notes. It's right in here. Here is something that you guys need to commit to memory. Anything times its reciprocal is always 1. And it's a very, very easy thing to commit to your memory. And this, I'm just going to backtrack, not that you guys have to in your notes. Cosecant is 1 over sine. And if you look at it that way, the signs cancel out. So anything times its reciprocal, sine times cosecant is 1. If you had tangent times cotangent, well, it's always a 1. Now here's where, for our first question, we are done. If we look at the Pythagorean identities, 1 minus sine squared is equal to or replaceable by cosine squared, and we have done it. Okay, so we have proven this identity that both sides are technically the same. Yes, we only worked on one side, but we got it to look identical without breaking any rules of trigonometry, identities, or even just math in general. So this is the name of the game. Now just make sure when you guys are doing assignments, you have to show every single step. You have to show the equal sign in the middle. Don't show it out front. And I know that this seems like a redundant step, but you do have to, in the end, finish with cosine squared equals cosine squared to receive full marks. Now, when we move to the next question, off of the sheets, it will be number 5. And on the sheets, this was the original question. It started off with a tangent squared on the left side, and then on the right side, a secant x plus 1, and then a secant x plus 1. Guys, make sure you're still putting in the x or the theta, the angle symbol that is making it technically correct. Now, for this guy, if I just, first of all, again, asked you some questions, which side do you want to work on? Probably would be obvious, let's work on the right side. I don't know what we would do on the left side that would be that dramatic. And then the second question is, what would your instincts tell you? Then I would say trust your instincts. When I look at this, it's telling me to FOIL, so I'm going to. If I FOIL this out, first times first is secant squared, and if I stop making dumb mistakes, that's actually a minus sign in the PDF notes, and that makes it even better. The word that describes this relationship is a conjugate, because it's the exact same terms with opposite signs, and the conjugate is beautiful. The outer and inner always cancel out, we don't even do it, and we are left with a minus 1. And now, for our grand finale, we have it. Anytime you see squares and 1s, drop your eyes to the Pythagorean identities, and most likely it's going to be something there, and this is the second identity that is equal to or replaceable by tangent squared. And so we've proven our identity. The next question that we did off of the sheets, or we have to do, is number 9. Number 9 says, let's prove that cosine squared x plus cosine squared x tangent squared x is technically equal to 1. Now, this one's going to be an easy one for which side should we work on. There's nothing to do with the 1, so let's do something here. And what you are seeing quite nicely is a lot of the key rules jumping out at us. For this question, we are going to do the opposite of doing a FOIL or the distributive property. We're going to do a factor. Cosine squared is one term. Because these guys are connected with a multiplication, they're a second term. What we can actually do is we can factor out a cosine squared. When I take it out of the first term, you're left with just a 1. When you take it away on the second term, you're left with a tangent squared. If there's a tiny question mark in your head, distribute it back in, and it proves that we did it right. Now here is where, okay, again, anytime you see squares and ones, take your eyes immediately to the Pythagorean identities, and this one doesn't even require any of the manipulation that was done in the first two problems. It just 1 plus tan squared is equal to secant squared. It's replaceable. Now here's what's really neat too. Like in the first question, anything times its reciprocal is always going to be equal to 1. Well, if it's cosine squared and secant squared, as long as those powers are the same, it is still a 1. And we have proven the identity, that both sides are technically equal. We had this side manipulated to equal a 1. For the second last identity that we are going to prove, again, that comes off of the sheets, this one starts to look a little weird, but it comes together really quick, really nicely. What it does is it starts off with secant to the power 4 minus tangent to the power 4 equals secant squared x plus tangent squared x. Now, if I asked you guys to, again, think of what would you do, trust your instincts, you might tell me that your instincts are to run away, but don't panic. I'll start you guys off, and this one works out quite nicely. This actually is something that can be factored. And here's your quick little brush up. In the old days, if I had x squared minus 4, well, it would factor to x minus 2, x plus 2. If this was y squared, well, it factored to x minus y, x plus y. And then if it was to the power 4, it would factor to x squared minus y squared, x squared plus y squared. That is just a bigger version. The trigonometry might just throw you off the trail for that. This actually factors, and it factors quite nicely. It factors to secant squared x minus tangent squared x, and then secant squared x plus tangent squared x. The word conjugate still comes in. And then we have to write down this other side. You can never leave that blank if you want to get full marks. Now here's what is really neat. You might be like looking at this saying, well, what did we just do? Did we make a mess? No, we didn't. If we look at our identities and we just manipulate one of the Pythagorean identities, secant squared minus tangent squared is just a 1. And then if you take stock of what you're left with, we are done our second last proof. We have, on the left side, secant squared x plus tangent squared, and we also have the same thing on the right side. We have proven this identity. Now, the last one that we are going to prove is quite a nice one. It does factoring, and then it adds in one of my favorite things ever to do, which is the crossing out. So this identity on the sheets, number 19, has 1 subtract sine squared, 1 minus sine to the 4th x divided by 1 plus sine squared x, and then we're supposed to show that this is technically equal to cosine squared. Now, here's something that you can't do, and we've been kind of talking about this for a couple of courses now. You can't just randomly take a 1 and a 1 away or a sine and a sine. You have to take it away only when there's multiplication. This add and subtract get in the way. If that is not making sense in your brain, I would actually research that. There'd probably be a few good videos or pages where you would see why it is technically incorrect, and they might prove it with simple numbers. So then we have to do something else. Now, we're going to work on the left side. I'm not sure what we would even do on the right side. Some questions, they're designed where you want to do a little bit on both sides because this is fairly simple. Let's just work on the left side. We're going to leave the denominator entirely alone. It really is the numerator. 1 minus sine to the 4th x. You might have the instinct, because of this previous question. It actually factors. It's a conjugate idea. It factors to 1 subtract sine squared x and 1 plus sine squared x. It's the conjugate idea, and you could FOIL it out to see it takes you back to 1 minus sine to the fourth. Now here is where this is legal. Because there is a multiplication here, we can do one of my favorite things ever. We can take that entire thing away and that entire thing away. They divide to 1, and again, because it's a multiply, timesing by 1 doesn't do anything. So we are left with 1 minus sine squared x equals cosine squared x. Now, the bad news is I'm almost out of room. The good news is we only have one step left. Again, we drop our eyes to the Pythagorean identities. 1 minus sine squared is cosine squared. That's what it's equal to. It's replaceable by. And we continue writing down the other side. We have proven it. Both sides are technically the same. They're both cosine squared.